Hi, today we are going to learn about the first ionization energy. Lot of students they think it's hard, whereas it's not. It's very easy. There are two things. First thing is you got to retain. The second thing you should have the capacity to recall as well. All right. Okay, with me, let's start. One, two, three, go. First ionization energy. First ionization energy with clear letters. With me, write the topic down. First ionization energy. Now, yes, what's first ionization energy? What does it mean for you? First ionization energy. At the exams, they'll be asking you for the definition, and you should be fully competent to answer it in a go. All right. Now, one of the first few things you should know is when it comes to O levels, they'll be having a marking scheme. Okay. And in the marking scheme, they don't have the exact, or rather, they don't have the full definition on the marking scheme. No, what they have is keywords. Certain keywords are there, and most of the teachers they'll be going through what you write. They'll just see whether you have mentioned the keywords, and when they say the keywords, they'll mark it right. So it's very expedient for you if you can also um culture the same. Okay, so let's base it on keyword. The first ionization energy, yes, it's about an energy, a minimum energy. Okay, it is about the minimum energy which is required to remove one electron out from an atom. Since here we are talking about the first ionization energy, we are talking about the removal of one electron. Removing of one electron out from an atom of an element to form a unipositive ion in the gaseous state. All right. When you remove one electron, what happens? The atom becomes an ion, and since it's one, it will be unipositive. Uni means one, unipositive ion. It will form a unipositive ion in the gaseous state. Here we are talking about the gaseous state. Okay, watch closely. Now here we mentioned about, okay, I can break it down to four main keywords. Okay, the first one is minimum. It is very crucial to remember the word minimum. All right, just imagine someone's pulling my arm from the other side. Someone wants my arm so bad, and then they start pulling it off, but I'm holding it towards my side. Okay, I'm holding it towards this side, and because I'm holding it towards this side, the other person from that side cannot really take my arm or get my arm to the other side. Okay, what should that person do if that person needs my arm? Yes, that person got to pull the arm. That person got to use energy and pull it from the other side. But I'm also holding it from this side. Just because, okay, that person doesn't really need to use the fullest energy, right? The fullest strength. There is a minimum level. All what you got to do is, or you need to pull it from the other side more than the bond I have from I have with my other hand, right? There is a bond. I'm holding it my arm with my other hand. The person who's over there does all what that person needs to do. Pull it from the other side in a minimum level, just so that exceeding the bond I have between my two arms. All right, that person doesn't really need to necessarily. It doesn't mean that person should use the entire strength. All right, something like that. It's very simple. The minimum energy. There is a minimum energy you can remove an electron with, and then you can say energy. Energy that can also come as a keyword. Energy. We are talking about energy here, and also unipositive. Unipositive. All right. and gaseous state. Gaseous state. Okay, those are the four main keywords. If you can just remember the keywords and base your definition on the keywords, you're golden. Okay, remembering four simple words is much easier than remembering a whole definition. Okay, what you should do is first get the understanding, be rooted in the concepts. Okay, and then formulate your own answer using these keywords. It's that easy. All right. Okay. With me, let's write a definition for the first ionization energy. The minimum energy. Okay, write it down with me. The minimum energy which is required or needed to remove one electron, to remove one electron or to remove an electron out from an atom, out from an atom of an element, out from an atom of an element to form a unipositive, to form a unipositive ion in the gaseous state, in the gaseous state. That's it. That's all to it. Simple enough? Clear? Okay, awesome. Now we are going to talk about how the first ionization differs across a period, and what happens when you go down a group. How does it change? Does it uh, go up or down? We are going to talk about how it changes. Okay, now the first question I'd like to ask you is, why do we need to supply energy, or why is energy required to remove one electron? These are the questions you should, the questions which should arise in your heads, right? As people of science, you got to always ask why. Why does it? Why do we need an energy to remove? Now, if you go back to the atomic model which was proposed by Rutherford. Okay, what he told was, just like how the planets are revolving around the sun, these electrons are also revolving around the center mass. In the mass, okay, in the mass, there were, what was there in the center mass? There were protons plus neutrons. Yeah, in the center mass. And electrons were revolving around the center mass. And then, since the nucleus, which is the center mass, is in the center mass, there are protons, right, which are positively charged, and electrons are revolving. Now, since protons are positively charged and electrons are negative, there is an attraction between the center, between the nucleus and the outer shell with the electrons, because negative and positive, they attract. So there is an attraction. Now that's exactly why we need to supply energy to break this attraction. If you want to, if that person wants to take my arm, that person should supply energy more than what I have in between, right? Just in the same way, if we need one electron to be removed out from here, we need to supply energy so that the attraction, like in a way, the energy should be more than the attraction. If we can really exceed the attraction between and supply energy more than that, we can probably, there's a good chance that we can get the electron removed. That's why we need to supply energy. All right. Okay, now what happens when you move across a period? What happens to the first ionization energy? All right. Okay, tell me what happens when you go down a group. What happens to the first ionization energy when you go down that's right, yes, it reduces. Why? When you go down a group, in the center again, I have to draw this. Protons are, neutrons are there, neutrons are negative, neutrons are neutral, protons are, yes, positive, electrons are revolving around the center mass. Electrons are negative and the attraction is there in between. Now, what happens when you move down a group? What happens when you move down a group? Energy shells are added, right? When you move down a group, if you are talking about lithium, you will have how many energy levels? Yes, you will have two energy levels. If you're talking about sodium, you will have three energy levels. And when we are talking about the last energy level, will be removing one electron out from the last energy level. Now, what happens to the distance between the center, between the nucleus and the last energy level? The electron which is in the which is at the last energy level, what happens to the distance between? It increases. Yes, when you move down a group, energy shells are added. So the distance between the last energy level and the nucleus, it increases. Therefore, the attraction in between decrease. Therefore, the attraction in between, because the distance between the charges increase, and because of the increase in distance, okay, because of the increase in distance among the two charges, the attraction decreases. All right. So the minimum energy which is required to remove one electron, what happens to the energy? It decreases. You don't need to supply energy, a lot of energy, as how you did when the distance is short. All right. So when you move down a group, the first ionization energy levels should decrease. All right. Simple enough. Awesome. Okay. Next, what should happen when you move across a period? Across a period. All right. Okay. This is how it would vary. At the exams, they'll be asking you to draw the graph how the first ionization energy would vary across a period. Okay. All right. So here we can, this side we can have the elements, and here we can have kilojoule per mole, the energy, basically the energy. Okay. Now, starting with hydrogen, all right, starting with hydrogen, the first ionization energy would drastically be increased when it gets to helium. Why is very important. Why does helium have a higher first ionization first why does helium have a higher first ionization energy? Because they are stable in nature. They have a stable electronic configuration. Therefore, they don't need to change it. There's no reason for them to let go an electron. Because why? Because they are already stable, right? So a person or an element who's not stable right now, or let's say comparatively less stable, would like to give a electron now, or would like to gain an electron and to go for and to obtain a stable electronic configuration. Since helium already has a stable electronic configuration, it would not go for a, or it would not prefer a change. All right. Now with helium, what are the other? We call helium a noble gas. Why? Because it has a stable electronic configuration. With helium, there are two other noble gases. What are those? Yes, helium, neon, and argon. 2, 10, and 18, according to the atomic numbers. Okay, all right. From helium, since helium has a very high first ionization energy, after helium, the first ionization energy drastically goes down, all right, and get to lithium. And after lithium, it will again start increasing to beryllium. It will start increasing beryllium. After beryllium, the first ionization energy would decrease when you get to boron. Okay, the reason here would be beryllium is more stable comparatively comparing to boron, it has a good stable electronic configuration. Therefore, the first ionization of beryllium is higher than boron. After boron, again the first ionization energy rise. Okay, after boron, it's carbon, it will rise, and again after carbon again it will rise until nitrogen. Okay, once it hits nitrogen, again there's a slight decrease when it comes to oxygen. Reason being, nitrogen is comparatively stable in nature, therefore the first ionization is slightly higher than oxygen, and from oxygen it will again rise to fluorine, and then again it will peak at neon, again which is a noble gas. All right, simple enough. Now, just like, yeah, exactly. After neon, again it will drastically go down. Okay, until you reach sodium. Okay, now what you need to consider is this level should be comparatively lower than lithium, right? The first ionization of energy should be lower than lithium. Why? Now another extra energy level is added. It has gone down a group. All right. Now the same pattern goes on. It's very easy. Now this same pattern again gets replicated here. After sodium, again it rises to magnesium, and again after magnesium the same thing, it goes down uh, to aluminium. When it gets down, when it comes to aluminium, again it slightly decreases. The reason being, magnesium is much stable in nature, therefore the first ionization energy is comparatively higher. And from aluminium, again it rises to silicon. Okay, and again it rises to phosphorus. Okay, after phosphorus, again it goes just like the same, it's the same pattern. After phosphorus, again it goes down a bit. Okay, and gets to sulfur. Okay, from sulfur it keeps on rising to chlorine, and then again it would peak at argon, which is a noble gas. All right, and from argon it has to again go drastically down, and you will get potassium. All right, this is the pattern. This is all what you need to remember. It's nothing hard. It's very easy actually when you think about it. All right. What you will be questioned is on how the pattern varies across the period and across the group. You got to be based up. You got to be based on your concepts and understanding and say this right. It's very easy. And also notice lithium, sodium, potassium. They have the lowest first ionization energy. Because if you remember its electronic configuration, if we are talking about sodium, it will be 2, 8, and 1. What is the closest stable electronic configuration? Yes, it's neon electronic configuration is the closest stable one, which is 2 and 8. Altogether 10, 2 and 8. So sodium has 2, 8, and 1. It will gladly remove one electron. It is waiting to remove one electron. So එන්නත් කලින් අහන්නත් කලින් දෙන්න ලෑස්ති වෙලා ඉන්නේ. So it is so the first ionization energy of sodium would be pretty low. Okay, comparatively the elements of the first group, they have the lowest first ionization energy. With that, if you got any questions, comment below. See you soon.